Show that each sequence is arithmetic. Find the common difference and write out the first four terms. So what we're going to do first here is we're going to show that the sequence is arithmetic. That simply means that it has a d that it's adding to each term, and that d is just the difference, the same number I'm adding to each term as I move out. So to do this, essentially what we're doing is we're using the formula d equals some sequence, I'll call it a sub n, that's generally what I use, a sub n, oops, don't need that anymore, minus an minus 1 is actually a constant. So that's what we have to show here. So for instance, if I call this my sequence, just to give it a name, a sub n, and I'll call this one then b sub n, just so we have names for them. So when I actually write this out now, I'll just take the nth term. So that means this piece right here is just going to be 1/2 minus 1/3 n. So that's the first one. Now what I'm going to do is I'm going to minus, see, all of this right here is this, just so you know, is the a sub n. Okay, so now for an minus 1, I'm going to use a parenthesis here, and I'm going to say 1/2 minus 1/3, and in place of the n, I'm going to put n minus 1. Now I have to use a parenthesis here because this is a times, and this is a times here. So I have to use parentheses because it's n minus 1 that I'm timesing. Okay, so anyways, that's where people, if they did this, would probably make a mistake. So be careful. Okay, so anyways, now I'm just going to simplify this. So I have 1/2 here minus a 1/3 n. I can't add those together because they're not like terms. So this is minus 1/2 plus 1/3 n minus 1. And I keep that in parentheses because I didn't do anything with it yet. All I did here was essentially I have like a 1 here, negative 1, and I distribute it through those two terms. Now remember, terms are separated by pluses, minuses, and equal signs, so be careful with that. Just algebra here, but it can catch you up if you don't use it very frequently. So anyways, so there we go. So now I can see that when I put these together, they're going to cancel because I have a positive here and a negative here. Okay, and also I have I gotta distribute first. Let me do that first. I'm getting a little ahead of myself, but yeah, I'll get rid of those right now. It's not gonna matter. Okay, so anyways, so now I have a negative 1/3 n plus, and I'm just gonna distribute this piece now. So that's gonna be 1/3 n minus 1/3. So what we see here now is also those 1/3s cancel out because one's positive, one's negative. So now we end up with just 1/3. And would you guys agree that 1/3 is a constant? So that simply means then that this would be an arithmetic sequence for that reason. Now if I had an n left here, like an n there or something like that, that means it wouldn't be a constant anymore. It would change. So therefore it wouldn't be a arithmetic sequence. But since it does, it is. Okay, so that's how we tell. So say from that we can say this implies, and I'll just write the sequence a sub n is a n arithmetic sequence. And then it also says find the common difference. So in this process, we actually found it too. It's actually 1/3. So in finding it, we prove that it was arithmetic. So that's kind of how it's done. So let's just do the other one really quick now. So no different here. Actually, it looks a little more difficult though. And I do have to understand the rules of b sub n, that it's ln of 3 to the n. Because this is what I want to do first for this one. I want us to think of ln of 3 to the n, and using the power rule of logs, or power rule for logs, I can take this power and bring it down in front of the log. So that means this would really be n times ln of 3. So that's really what it is. And we're going to use this property to actually show that this is a common difference, to actually work with these. So again, what do? I say d equals, and I would say b to the b of n minus b of n minus 1, or b subscript n minus 1. All right, so this is what we have. So now all I'm going to do is plug those values in for that. So bn is going to be this n ln of 3. And then minus bn minus 1, I have to use parentheses here because this is a times. So that means that's going to be an n minus 1 times ln of 3. So now from here, I'm just going to distribute. Okay, so that's going to equal n ln of 3 minus, and I'm going to use a bracket here just so I don't screw anything up, because this negative and this n minus 1 in here can sometimes mess you up with one of your terms, and you'll see what I mean in a second here. So I keep it in a bracket there, and I'm going to distribute this through now. So this is going to be n ln of 3 minus ln of 3. So now I'm going to take care of this negative out there. And this is going to equal n ln of 3 minus n ln of 3 plus ln of 3. Now I have to make sure I multiply that negative through, and this is the one people would generally mess up on, would be the second one here. So just be careful with your signs and distribution. So now what happens here is those cancel out because, again, they're different signs. So I end up with ln of 3. And I don't know if you know this or not, but ln of 3 is a number. So we found the common difference like we did in the previous problem right away. Okay, and because we have this, this implies, and that's a constant, I should say. Got to be careful because it's a constant. Then I would say b sub n is an arithmetic sequence. So there's our answers for those two.